Hey guys, today we're looking at lesson 8.2, the natural base E, and we're going to start with task 1. All right, so today we're going to look at the number E, and I know you're thinking it's not a number, it's a letter, and that is true, but E is an irrational number like pi, and it's actually a very important number in math, and most of the time you don't learn about it until you get to Algebra 2. So we're getting ready to move into something called logarithms, and E is something we use when approaching logarithms. We also use it with exponential functions and interest rates and things like that. So let's get started. All right, to graph and analyze the function f of x equals e to the x power, the table shows the function f of x equals 1 plus 1 over x raised to the x power for several values of x. All right, so you can see in the table they start with 1 and jump to 10, 100, 1,000, and 10,000. And when they do that, you can see what happens to your y value. So it goes from 2 to 2.5937, 2.7048, 2.7169, 2.7181. All right, so notice as the values of x increase, the values of y, or f of x, is approaching the decimal 2.718. This number is a special irrational number like pi, and it's called E. All right, so use your calculator to complete the table of values for the function f of x equals e to the x. Where necessary, give the first 3 digits displayed after the decimal point. All right, so if you pull up your calculator, you see that pi is in blue right here, and e is right underneath pi. Okay, so it's in blue, which means when you use it, you have to use the second button. All right, so we want to do e to the negative 1 power. So the first thing I'm going to do is find my e. So e raised, because it's an exponential function, e raised to the negative 1 power. And then enter. So this one's going to be about, let's see, where necessary, give the first 3 digits after the decimal point. Okay, so 0.3678, that's probably going to round to 3.68. All right, anything to the 0 power, e to the 0 power should be 1. Let's go ahead and check it. We know that from properties of exponents. So e raised to the 0 power equals 1. And then e to the first power is going to equal just e, which they're giving us as 2.718 would be my first 3 decimals, or 3 places after the decimal. So 2.718. And then we want to raise it to the second power. So we're going to square it. So e squared is going to be 7.389. All right, let's see. It's saying the first one's incorrect. Let's go back. Maybe they did not round it. 0.367. Anything says 0 power is 1. 718. And let's see, the last one was 7.389. Okay, so they didn't round it on that first one. All right, it says plot the points from the table on the graph and draw a smooth exponential curve connecting the points. Okay, to save a little bit of time, I'm going to go to my calculator and I'm going to do e to the x power, and I'm just going to graph it using my calculator. So e to the x power, and I'm going to hit graph. And I'm going to see it looks like a smooth exponential growth curve like we've looked at in the previous units. All right, the value of E lies between the integers 2 and 3 on the number line. Remember, it's 2.718, which is between 2 and 3. How would you expect the graph of f of x equals e to the x to compare to g of x equals 2 to the x and h of x equals 3 to the x? Well, it's probably going to be somewhere in between those, but let's look and see what happens if we graph those as well. All right, so we're going to say we've got e to the x is already in here. Let's do 2 to the x power, and let's do 3 to the x power, and then let's hit graph. So the first one's graphed. You can see it's graphing 2 to the x underneath it, and it looks like 3 to the x is just above it. All right, so as x approaches infinity, so x approaches infinity is going to the right, f of x equals e to the x will lie in between 2 to the x and 3 to the x. All right, so you can see they graph the ordered pairs here. The table we made above where we substituted these values in, and we did e to the 0, e to the first, e squared. That's just visually seeing those points graphed out. All right, the graph of f of x is shown using a graphing calculator to graph f of x, g of x, and h of x on the same coordinate plane. What do you notice about the graphs? Select all that apply. All right, so here we can see that a lot of the things are very much the same. So they have the same domain, that's true. They have the same range. Well, they're all three above 0, that's true. They have the same end behavior. They're all approaching 0 on this side and infinity on this side. They have an isotope of y equals 0, that's true. They all approach this line here. All three graphs go through the point 0, 1. Okay, it's kind of hard to see there, but it does look like they all go through the same y-intercept. We can check the table if you want. And you can see 0, 1, 1, and then if we scroll over, they all have a 1 there. So that is true as well. And then the graph lies between 2 to the x and 3 to the x. So we said that was true as well. All the points on the three graphs are identical. Well, that's not true. They're not all identical because you can see 3 different lines here. So domain's the same, range the same, end behavior, isotope, y-intercept. This one's true because e to the x does go between those. So the only one that's not true there would be the last answer. All right, it says use the graph of f of x equals e to the x power to identify the following key characteristics of the function. All right, so the domain goes in both directions forever, so it's all real numbers. The range was everything above 0. The end behavior, you can see the end behavior on the left was approaching 0 and infinity on the right. And if you just kind of look here, you can see how it approaches 0 on the left. That's towards x equals negative infinity. And then as x approaches positive infinity, it's going to infinity as well. The intercept is 0, 1, and the isotope would be at 0 as well. All right, how do the characteristics compare to the general graphs of f of x equals b to the x, where b is greater than 1? So this is your general exponential function that we looked at before. So it says the graphs are the same. The graphs are the same for these characteristics. The graphs have some of the characteristics in common, but not all. The graphs have none of the characteristics in common. Well, if we go back up here and look, it had all of these characteristics in common. They're not identical points, but as far as the characteristics go, I believe they have the same characteristics. All right, that's all for task 1. If you have any questions, please let me know. All right, guys, this is lesson 8.2, Natural Base E, and this is task 2. All right, transformations of the graph of f of x equals e to the x. All right, in the last task, we just learned what e is, and now I want you to understand that transformations will be very much the same as other exponential transformations. So it says the general form of the transformation of f of x equals e to the x is g to the x equals a times e raised to the x minus h power plus k, which is similar to the general form of the transformation of the exponential function with base b. The table shows two reference points and the isotope of the parent function f of x equals e to the x, as well as the corresponding values of the transformed function. All right, so as you can see, f of x equals e to the x, and it gives you the reference points just like we did in the previous lesson. And then the a and the h and the k are going to be found the same way as well. So here's the ordered pairs for the reference points that you can jot down in your notes just to have. All right, notice that these functions are identical to the exponential function seen in the previous lesson. F of x equals b to the x, and g of x equals a times b raised to the x minus h power plus k when b equals e. So again, instead of having base b, which in the previous lesson was a number, now we're going to use e, which is a number, but it's a special number. It's the same number every time. It's that irrational number, 2.718, etc. All right, so graph g of x equals 1/2 e raised to the x plus 5 power minus 2 using reference points and isotope. So identify the parameters a, h, and k. So you can see a is 1/2. H is opposite whatever this is, so -5, and then k is -2. So remember again that this is going to be your horizontal movement, this is your vertical movement, and A is your vertical stretch or compression. All right, so use the parameters to find the reference points and the isotope. All right, it says, how do you graph points such as -4, comma, 1/2 of e minus 2? All right, it says there's no way to do this without a calculator. Well, there is if you know that e is approximately 2.718. So it says simplify the coordinates using that approximation for the value of e. And that'll get you very close when you're graphing. All right, and then you graph the points here and sketch the curve. So you can see this is the transformation of the parent function. Is transforming f of x equal e to the x power a special case of transforming an exponential function with base e? Yes, it works exactly the same. It's just e is a special case because of being an irrational number and being the same number all the time. All right, that is all for task 2. If you have any questions, let me know.